testing will have 5 steps, and in the end we are going to make a judgment or make a choice between rejecting the null hypothesis or accepting it. So let us start. The first step, we have to set up the null hypothesis. Whenever the based on the question that has been given to us, or based on, if you're talking in terms of your research, based on the objectives that you have framed for your research, or based on the variables that have been recognized for the research, you will have to decide what is null hypothesis and what is alternate hypothesis. So you are usually framing a null hypothesis and alternate hypothesis, and the step 2 is to select a significance level. That is, you find out what is the level of significance. Most of the times, in most of the questions in the exams, you will have 5% level of significance or 1% level of significance. Most of the questions we are going to see would be 5% level of significance. If they give, if it is specifically mentioned, then we use whatever the level of significance has been mentioned. If not, we generally assume it to be 95%. That is 95% level of confidence level, or the 5% level of significance. Then coming to next step, we have to calculate the test statistic. So based on what test you are going to conduct to either accept or reject the null hypothesis, we are going to use that particular test statistic. Now we have two types of test. One is large sample test, another one is small sample test. In the large sample test, you have 4 kinds of tests which has been given in your syllabus. First one is test for one mean. Second one is test for two means or difference of two means. Third one is test for one proportion, and fourth one is test for two proportions or difference of proportions. Now basically there is no specific count to decide whether it's a small given sample is a small sample or large sample. Basically we consider the samples. There is no specific distinction between what number should be taken to call a given sample as a small sample or a large sample. Basically what we do is, if the sample size is greater than or equal to 30 observations, we consider it as a large sample, and we use the formula which has been mentioned below. And if the number of observations or the sample size is less than 30, then we basically solve those problems with the help of small sample test. So here if you see, we have for one sample you have z cal is equals to x bar minus x naught by sigma by root n. So this is your test statistic. This is the formula. You will be given all these parameters in question. You will have to calculate putting these values in the formula. Now, so we have, this is the formula for one mean, that is x bar minus mu naught by sigma by root n. Now coming to difference of two means or two means. Why do we call it difference of two means? Because we are subtracting x bar minus y bar. X bar is one sample, mean for one sample, and y bar is mean for another sample. So we are taking the difference of means between these two samples. That is why we can also call it as difference of two means. So the parameters, based on the parameters, we calculate the z-cal value. Now why am I using z-cal here for all these tests? Because we will also need to find a z tabulated value, z tab. Okay, so z is nothing but the normal distribution variate. So standard normal variate. So standard normal variate means we need normal distribution table values based on the level of significance, we will identify the tabulated values from the table. So once we find the tabulated value and the calculated value based on the test statistic, we compare these two things to give a judgment on the null hypothesis. Okay, now these 4 tests are for large sample. Coming to small sample, we have we use t distribution. Previously we have used z normal distribution, that is z, standard normal variate, to calculate the test statistic. Now here in the small sample test we will use t distribution. T distribution is also called standard t test. So we have a table for t distribution also. So based on the parameters what we have, we find the table value and then compare it with the calculated value and give a judgment on what kind which hypothesis, either null hypothesis will be accepted or rejected. Coming back to the procedure now, so that was about the test statistic. Now step 4, using the test statistic, level of significance is alpha, and the type of test. Now what is type of test? Type of test we have seen in the previous session. You could have one tail test or two tail test. So in the first step itself, when you define your null hypothesis and alternate hypothesis, you will also decide what kind of test are you going for. Is it two tail test, one tail test, two tail test, or one tail test? If, for example, if I define h naught mu is equals to mu naught, okay, and if I say h, now alternative hypothesis might have 3 options. One is not equal to, other one is greater than, another one is less than. 3 options. So for this, if you remember, we have we will do a two tail test, because we have tails on both the sides of the curve. For greater than, if we have a greater than symbol, then we draw a tail towards the right side of the normal distribution curve. If it is less than, then we draw a tail towards left hand side of the distribution curve. So this is how you will also define what type of test are you going to consider when you define the hypothesis, the alternate hypothesis. So once you do that, you will obtain the critical value is nothing but the table value. So for example, this is your normal distribution curve and you have alternate hypothesis mu greater than mu naught. Okay, so you are using a right tail test. In this, if your, so this is the border, this is where your z tab will be useful for you. So z tab, this tabulated value will divide the acceptance region and the rejection region. This is your rejection region and this is the entire part. So this entire part is the acceptance region. Now if your the calculated value, the test statistic value, if it falls in the acceptance region, then we say, then we are accepting the null hypothesis. If it falls in the rejection region, we reject the null hypothesis. Okay, so if you read this last line, you will understand. Compare the value of test statistic and a critical value. Critical value is nothing but the tabulated value. Make the decision about rejecting or not rejecting the null hypothesis. If the test statistic falls in the critical region, that is the rejection region, reject the null hypothesis, else accept it. Okay, so these are the 5 steps that will help us making a judgment on the null hypothesis. The first one is to frame the null hypothesis and alternate hypothesis. In this step itself, we are going to decide what type of test we are conducting, whether it is one tail, whether it is a two tail test or right tail test or left tail test will be decided in step 1 itself. Then step 2, we are finding out the level of significance. Basically we assume it to be 5%. If they specifically mention, we take whatever percentage is mentioned in the problem. Then third step is to calculate the test statistic. Now at this point in this step, you will see if the sample size is greater than 30 or if it's less than 30. If it's greater than 30, then you will see the large sample test. Whatever if you have whatever parameters are given in the question, based on the parameters you will choose which formula could be used for testing the hypothesis, and you calculate your test statistic. In step 4, you will obtain the critical value. Critical value is nothing but the tabulated value. In step 5, you compare both calculated value and the tabulated value, and you see if the calculated value is falling in the critical region or the rejection region of the curve, or if it is falling in the acceptance region. If it falls in the rejection region, we reject the null hypothesis, otherwise we accept. Okay, I hope you have understood the concept. We have basically I'm trying to focus only on the problems at this point of time. Once you are well versed with the problems, we can see how this could be I will give a demo on how this could be used and solved in a research problem. For example, maybe we could take a research article and see how people have used testing of hypothesis and how the hypothesis has been framed. We will try to have a practical session once we finish this unit. If you have any doubts, please post in the group. Thank you.